Good morning and welcome to part 1 of section 4.2. After having to record 4 videos, for 4.1, I'm guessing I might have to split 4.2 into 2 videos looking ahead at the material here. So 4.2 is about graphing polynomials. And in the last section, we talked about the leading term test, and we're going to be using that. And we're going to be using one other characteristic of polynomials to help us. And we're going to be able to come up with a pretty accurate graph for these polynomial functions. So you might want to review real quick so I don't waste a whole bunch of time on this recording. Remember, I can only do 15 minutes at a time. The leading term tests. And I'm going to draw the chart in the corner here. I'm going to draw it small just for us to reference. And this was in 4.1. Because we'll be able to use the leading term test to help us decide what the ends of our polynomial graph are doing. And then we're also going to be finding the zeros, or the x-intercepts, to decide what's happening in that big squiggly section in the middle we were drawing. So remember, with the leading term test, really quickly, we were going to look at whether the degree was even or odd, and whether that leading coefficient was positive or negative. So there would be 4 different options on what the ends of our graph could look like. The coefficient a sub n tells us what the right-hand side is doing. So if it's positive, the right-hand side's going up. If it's negative, the right-hand side's going down. And then the degree of our polynomial tells us if the left-hand side is doing the same as the right, or if it's doing the opposite of the right. So if the degree is even, we've got a bunch of stuff in the middle, but then the left-hand side does the exact same thing. Bunch of stuff in the middle, but the left-hand side does the exact same thing. So positive and even both go up. Negative and even both go down. If our degree is odd, then the left-hand side is going to do the opposite. So if the right-hand side went up, the left-hand side goes down. If the right-hand side went down, the left-hand side goes up. So positive and odd is down on the left, up on the right. Negative and odd is up on the left, down on the right. So we're going to use this to help us decide what's happening on the ends of our graph. And these little squigglies I keep putting in the middle, we're going to be able to fill those in now with some better information, because we're going to be using our x-intercepts. Let's try to focus the camera here. We're going to use the x-intercepts, which we also talked about in the last section. X-intercepts and factors and zeros all use the same numbers. So even if we don't know what this graph looks like and we want to try to graph it without our calculator, we can find the zeros for a function, and those are the same thing as the x-intercepts. So the zeros of a function are the x-coordinates of the x-intercepts. Now there's still some parts of this graph that are not going to be completely accurate. So how low or how high the graph goes in between the intercepts, we're not really sure. So a pattern that we might see here with these polynomials is for some polynomial p of x, and it has degree n. There are some things that we may see. A degree n polynomial can have as many as n x-intercepts. It doesn't have to have that many, but it can have that many. And also, it can have as many as n minus 1 turning points. And that's how many times this graph changes direction, changes from increasing to decreasing, increasing to decreasing. So if it was a 5th degree polynomial, it could have as many as 5 x-intercepts, and it could have as many as 4 turning points. It could turn around and change direction as many as 4 times. So this would be helpful to know as well when we go to graph these. So let's look at a couple of examples. And I'm going to keep this right off the screen because this is all going to be really useful information in just a minute when we see an actual example. So we're going to use the leading term test. And the zeros to make a rough sketch of each polynomial. And we're going to look at 2 of them. So this first one is going to be fairly simple, but it's not going to be factored for us since it's simple. So we're going to have f of x equals negative x cubed plus, let's say, 5x squared minus 6x. We want to make a rough sketch of that polynomial without using our calculator. So I'm going to start off with the leading term test. My leading term is negative x cubed. And that tells me 2 things. It's negative, so the right-hand side goes down. And the power is odd. And odd means the left does the opposite. So the left-hand side goes up. I can also factor this polynomial. All of those terms have a negative x in common. And if I factor a negative x out, I'll be left with x squared minus 5x plus 6. And I can factor that one step further. And we need 2 numbers that multiply to be positive 6 and add to be negative 5. And that's going to be minus 3 and minus 2. And remember, the zeros are any numbers that make your function equal to 0. Sorry, missing my x. So now that it's factored, I'm saying that these 3 numbers multiply to make 0. That means one of them individually is 0. And we can solve them. And we get x equals 0, 3, and 2. So I've got 3 places where I know this graph crosses the x-axis. And I probably should have made that a little bit bigger. Or moved that graph up a little bit. Sorry about that. I'm not labeling anything on the y-axis, only on the x-axis. And I'm going to mark my zeros as x-intercepts. I know that 0, 0 will be an x-intercept. I know 3, 0 will be an x-intercept. And I know 2, 0 will be an x-intercept. So I'm going to look at my outside marks. I know on the right I go down. So from there, go down. On the left I go up. So from there, go up. And we need to connect them in between. So that's a rough sketch of what negative x cubed plus 5x squared minus 6x looks like. Now the only thing we don't know is how low it goes in between 0 and 2 and how high it goes in between 2 and 3. And there's one quick thing I should add to this, because I'm going to throw it into the next example, and that is the multiplicity for these zeros, which you have probably seen already. And multiplicity is really important. Multiplicity just is referring to the exponent that you see on a specific factor, or the number of times that one specific factor gets used in a polynomial. And we'll see an example in this next one where we have to use the multiplicities, because having a certain multiplicity means a certain thing on the graph. If your multiplicity is even, so we've got a factor that has a squared or a fourth or eighth power on it, that means if we're going to use that 0 as an x-intercept, when our graph comes down and touches it, or comes up and touches that x-intercept, it's not going to cross through the graph. It's just going to touch the point and then bounce back. So if we have an even multiplicity, the graph bounces off of the x-intercept. And I'm going to show you an example with this in just a second. If the multiplicity is odd, your graph is going to cross right through the x-axis at that x-intercept. Like we just saw in our last example, which I'll pull back out here in just a second. Graph crosses the x-axis at the x-intercept. And this is going to be important in our next example. But I'm going to pull out my the example we just finished here. If you look at these factors, negative x, x minus 3, x minus 2, I don't see any exponents on those factors. So remember what that means. That means an exponent of 1. 1 is an odd number. So each of these factors has an odd multiplicity. An odd multiplicity means that when we approach that x-intercept, we're going to cross right through the x-axis. So when I approached each of these x-intercepts, I crossed right through the x-axis. If any of these were to have an even number power on them, we would approach our intercept and then just touch it and bounce back. So example B, this one's already going to be factored because it's going to be a lot bigger. We've got 4x squared times x minus 1 times x plus 3 squared. And we want to sketch a graph of that polynomial. So in the first polynomial, when it's given to us in standard form, it's very easy to see the leading term and do the leading term test. But we have to do some work to factor it. When it's already factored for us, it's the exact opposite. We can't see the leading term right away, but we can see each of our factors and turn them into zeros and x-intercepts. Your leading term is going to consist of the leading coefficient, the coefficient here in the front, and each x and each power. So I've got a 4, I've got x squared, and this has just 1x. And this has x squared as well. It's x plus 3 squared. And we only want to know what the leading term would be. We don't need to FOIL all this out. So this would be 4x to the 5th. So it's positive. That means the right goes up. And I'm just about out of my 15 minutes, so I'm going to start a new video to finish up this problem. But I also want to say it's odd, so the left does the opposite and goes down.